Greetings of the day. Welcome to the course on Operations Research Technique. Students, you must be aware that we are now in unit number 3 and we are studying dynamic programming. In dynamic programming, in earlier lectures, we have seen what is the structure of dynamic programming problem, how to solve dynamic programming problem by methods in which one data was discrete in the form where the decision variables were greater than equal to 0 and it was mentioned as integers. There are other varieties of problems where the data will be in the form of continuous variables. So there such problems we will solve with the help of calculus method. So today what we will do, we will solve the problem which we have stopped in our last lecture and we will move from that point onwards. So if you recall, in last lecture we have state transformation for that particular problem, and we have also, this was the problem under discussion in the last lecture, and we were at this point. So these things we have discussed in our last lecture, which were important for this table. This table is for x2, that already we have seen in last lecture, just I am reminding, and this particular table is for x1, and we know that how x2 and x3 behaves. So x3 behaves like x3 minus 2y3 that we have seen, and this particular table behaves like, for this value it is x2 minus 3 times y2. So putting these values of x3 and y3 in this equation, we get these values for x2, and wherever that condition was not satisfied, we keep those places as dash, and wherever the condition satisfies, we wrote the value. Similarly we did for this particular table. Now what we will do, we will find step by step optimal solution. This problem was divided into 3 stages. So first we will find optimal for only one stage, then we will optimize it for first and second stage. The logic will be optimal solution of first stage and current decision of second stage. And in third case what we will find is f3 x3, wherein we will be finding optimal solution which you got at second stage, that is f2 x2, and current decision at third stage, that is f3 small f3 y3, that is current stage. So now what we will be doing, we will be taking help of this particular table for finding the value of f2 x2. You remember these values. Here there are 0, 1, 2, 3, here it is only 0, 1, 2 for values of y2. So now as we move ahead, for first this is our solution when it is, we are considering only one stage, that is f1 of x1. We know the values of y ranges from 0 to 7, and for those values of 0 to 7, if we multiply the value of y by putting all these values of y in this particular equation, step by step what we will be doing, we will be putting all the values of y1, right, 0, 1, 2, 3 up to 7 in this equation of f1 x1, which is equal to f1 of y1 being only first stage, assuming that we are looking for only single stage. So there we will be getting these values 0, 20, 40, 60, 80, 20, 120, this is 120 and 140. So simple, 7 into 20 is 140, 6 into 20 is 120, 5 into 20, 100, like that. Now this is very important table which we are be interested to get value of f2 of x2. So I am interested in this table, in this column. This is my important column for second stage. This is very important column for 2 stage. How to arrive at that is important. Now in our previous location, so for x1 we have right hand side value table where we have calculated the values for x1 by logic, and there we could get dash at these places. Now this table, this particular column is from this table, from table say 3. How? See here, f1 of x1 for 0 value, all values will be ranging from 0 to 140, 0, like this, 0, 20, in this fashion. If x1 we put for 1 the value starts from this point, so we are putting in place of dash, and we are rewriting the values of previous solution which we got as 0, 20, 40, 60 from this f1 x1. And in the similar fashion we have to write current decision. So the table columns which are for f1 and x1 will be replicated for f2 y2 for objective function 90 y1. Now again important thing, at dashes you have to keep dash, but the values at non-dash will be from this relation 90 y2. Now these are the values of y2, this is y2, this is x2. So y2 is equal to 0, 1, 2. So 90 into y2, if I put y2 0, all these entire values of column will be 0. If I put y2 equal to 1 in this equation, so this is 90 y2, so you will get 90 into 1, 90, 90 constant. Where there is dash, we won't put any value. If I put y2 is equal to 2, it will be 180. So where there was location in earlier table, that at that place we will put 180. So this is current stage decision. This is current stage decision, this column, and this is optimal solution of first stage. Now what Bellman's principle of optimality says, whatever your current decision, decision from earlier stage, your current decision will be taken at the situation prevailing at that point of time. So what we are doing, our objective function was in the form of summation of f and x for all 3 stages. So we are ready with optimal solution with first stage, if it is first stage. Now we are with current solution for second stage. So what we have to do, for getting this objective function of maximization, we have to add these 2 columns at respective location. So what we did, for getting this sum, for 0, for this 0 plus this 0 is this 0. So what I will do is, this is equal to, this column is equal to this 0 plus this 0. Similarly, this 20 is 0 plus 20, this 40 is 0 plus 40, this 60 is 0 plus 60. Likewise, here we get 90 So 90 is the result of what? 90 is the result of this particular value is the result of this 90 and this 0. Addition gives you this 90. Similarly, this 180 at this third column is the result of this 0, addition of this 0 and addition of this 180. So students, likewise in this tabular form we have to do calculations. If you commit a single mistake in addition and subtraction, you will not get optimal solution. You have to be very careful while writing the values. Now students, you are ready with f2 x2 and you are having 3 sets of values for each x2. So right now I am interested in maximum. I am interested in f2 of x2, but that should be maximum. So here for first row I am getting only one value, so no question of selecting maximum. 0 is the only value. Here only one value 20, here only one value 40. Now see here, this is very important. In this row, third row, I am getting 60 and 90. So amongst 60 and 90, 90 is maximum and therefore 90 is selected. Similarly, amongst 80 and 110, 110 is maximum. So what we did is, we have selected all these values which were maximum from this particular column, from rows. So I think this is very clear. Now we are ready with solution of second stage, and second stage solution is maximum of rows, that gives you final values of f2 x2. So these are the final values of f2 x2. Now we have solved near about 2/3 of the problem. Why I am saying 2/3? It was in 3 stages. So if you give equal weightage to the stages, first stage is 1/3, second stage is 2/3, third is 3/3, is complete problem. So now initially what we did, we have calculated initially in previous slide f1 x1, which was nothing but it was f1 of y1. This is our first stage. In this particular stage what we did, we have calculated f2 of x2, and the logic used was for f2 of x2 what we did, it is f1 x1 optimal solution of first stage plus current stage decision output decision y2 for second stage output is f2 y2. This addition we got f3 x3. Students, now the problem will terminate with last stage, that is f3 x3, which will be equal to, can you guess? Just think. In the similar fashion, it will be f2 x2 plus, that is optimal decision in previous stage plus current stage decision y3 and output from y3. So f3 x3 is equal to f2 x2 plus f3 y3. This is current stage. Got it? So now we will be finding last table. So last table runs like this. See these values, focus your attention on these values. For f2 x2 we got this set of values 20, 40, 90, 110, 180, 20. So that will be used as a reference for third stage, that I will show here. See here, we were having in previous slide, if you recall, this was our optimal solution for f2 x2. Now important is these places these places, if you recall our table for x2, we have calculated table for x2 by transformation of t of x3 and y3. You must recall all these important steps we have carried out. So for table of x2, for this variable we get for variable y3 equal to 0, 1, 2, 3 and x ranging from 0 to 7, these locations, we got these locations. Here it was dash at these places. Now what we did, again this is current f3 y3 is current decision, where it is equal to 17 to y3, 17 to y3. So again putting y3 value from 0 to 3 and multiplying that by 70, we get, by multiplying 70 by 0 we get all values 0. By multiplying y3 equal to 1 we get 70, 140, and y3 equal to 3, 73 are 210. These places were not satisfying the constraint values, and therefore we kept in this transformation table these values are dash. Same thing we are doing. Now whatever dash here, same dash will be reflected in previous solution, previous stage solution. So here what we did, we kept it same dash, and this was the optimal solution of second stage. So wherever dash ends, we are starting it from that point. So after 2 dash, again we are writing 0, 20, 40 like that. After dash 0, 40, 20, and here 0, 20. So it is the replica of the second stage, but variables are changed. Now as I said, I am interested in the value of this f3 and x3, and it is sum of these two values. This is previous stage, this is current stage. So same process as we did in previous slide, addition of respective columns. Addition of respective column, you get these 4 sets of values, and here for getting this your objective function, we are interested in the value of maximum value. So from these rows, we have picked up maximum value, like here 110, 140 is maximum. Got it? Here 160 is maximum. Here 180, 210 is maximum. Here 200, 230. We are getting at more than one places. Do not bother. We are interested in maximum value. So now students, we are ready with, this is tabular form method. It's quite lengthy one. Calculus method is simple, very simple. But if it is in the form of integers and the data is discrete variable, we have to solve it by tabular method, though it is time consuming method. But you have to be cautious while calculating and putting the values at respective places. That you have to remember. Now concentrate your attention on this, in this particular last. It is very important now. How to trace your answer, that I am going to explain. See here, your final value, you was interested in answer of maximize z value, maximize z, your value you are interested, and you got that value, and it is 230. So students, you know now maximum value which you are likely to get by putting different items into the cargo ship, into the vessel. But now our aim is to decide how much you will get, how much of each item, how much unit of each item we will place in the vessel, so as to give this value. Backtrace. Now we'll backtrack. How? See, this 230. Now this 230 you may got from this as well as this. Now in this situation, what we can conclude is this problem has multiple solution. It is very much true now. This particular problem has got multiple solution for putting those items into the vessel so as to get value of problem as 230. We'll see which are the multiple solutions step by step. Now backtracking, you have to be very cautious in backtracking. See here, this 230, suppose I pick it from this last, very important. I am not picking this from this, I say I am picking this from this third. Now I have to focus my attention on third column. So this 230 is sum of this 230 end column, third column is sum of this 20 and this 210. Students, very important, this 230 which is a replica of this 230, not this 230, is sum of this plus this. Now students, this 210 is a current decision. For that decision, your value of y3 is how much? Your value of y3 is, for this decision, your value of y3 is 3. Your value of y3 is 3. y3 is 3. y3 equal to 3. Now we have to backtrack for F2 x2 20 in previous slide. Keep in mind y3 as y3 equal to 3 for this maximum 210. Now our attention will be for this value of 20. You might have got in previous slide for F2 x2 maximum value 20. So we'll see that. Right now keep in mind this 30. So if you backtrack, see now, our intention is this. Our intention is now, again I will write from previous slide, we have concluded y3 will be equal to 3 and our F2 x2 in previous slide was 20. So here we have to see what will be the value of, here we will write y3 was 3 and F2 x2 was 20. This y3 was 3 for F3 y3, which was current decision, and we know that max value was 230, that we know. Now students, focus your attention on backtrack 20. So 20 is here, this is 20 is the F2 x2 value, and see here I am saying same value. So F2 x2 which is 20. Now in the similar fashion as we did for 230, we have to find from where this 20 come. So this 20 is the result of this 20 and this 0. So 20 is from this 0th This is maximum addition from this 0 column. This 20 is the result of 0 column 20 plus this 0. Now important, for this 20, your current decision of y2 says it is 0. Your current decision says that f2 of y2, for y2 value it is 0. Now backtrack this 20. 20 is from f1 x1, and students, this is a table of f1 x1, the table of f1 x1. If you find in f1 x1, now what you have to trace? In f1 x1, where is 20? Where is 20? So look for this row. 20 is at this point. 20 is at this point. So ultimately your value of y1 comes out to be 1. So here, if I take that 230, decision variables are we have taken item 1 y1, item 2 y2, and item 3 as y3. So what is the solution, students? y1 is 1, y2 yields 0, and y3 is 3. So you have to place 1 unit of y1, item 1, no unit from item 2, and 3 units of item 3, so as to satisfy the weight constraint of 7. If you recall that it was 7. So let us see whether that is satisfied or not. Keep this figure in mind. y1 0, y2 0, y1 1, y2 0, and y3 3. We'll again backtrack it. So this was the constraint. This was the constraint, students, and we get values of y1 as 1, y2 as 0, and y3 as 3, and max z as 230. So see, if I put here y1 in this equation, y1 is 1 plus 3 times 0 plus 2 times 3 is equal to, let us check this, whether this satisfies. This is 1 plus 6, 7 less than equal to 7. Yes, it is satisfied. So means our answer is, this answer is correct. This answer is correct. We will cross check the value of 230. So put 20 y1, maximum f, max f, 20 y1, 20 into y1 is 20, plus 90 y2, y2 is 0, plus 0, plus 70 y3 is 3, 70 into 3 210, so it is ultimately 230. Yes, so our one set of answer, students, for this dynamic programming is this one, and there is other answer for this that we'll see again, how to interpret other answer. That is very important. Again backtrack. Suppose for this 230, I consider now this 230. In earlier case I have considered this 230, now I will consider this second set of solution for the same 230. So this 230 is from second column number, this 2. So this 230 is sum of this 90 and this 140, correct? 140 plus 90, 230. Now for this 140, y3 is equal to 2. y3 is equal to 2. y3 is equal to 2 means I got for second solution answer of y3, that is 2. In earlier case it was 3. I got 2. Now I will concentrate on f2 of x2, 90. Remember y3 equal to 2. I will write for our reference. What we got is y3 equal to 2 and f2 x2 we were considering for 90. So this is for 90. This 90 is this 90 from middle column, which is sum of this and this. Very important. For this value of y2 is 1, so y2 is equal to 1. Value of y2 is equal to 1. Now focus for 0. For this 0, and y1 is equal to 0. So again you get a second set of solution which will satisfy your condition that objective function is satisfied, equal to 230, and these constraints are achieved with values of y3 2, y2 1, means the order is 0 1 2. Now we'll cross check here. Second solution which we got is y1 equal to 0, y2 we got 1, and y3 we got 2, and answer was max z was 230. We'll cross check. Put y1 0, put y2 is equal to 1, so this will be 3. 0 plus 3 and 2y3 is 4 less than equal to 7, 7 less than equal to 7. This is satisfied. So this is second solution, second alternative solution. If you put these values, you will get the same. 90, here it is y1 is 1, so 90 plus and 2 140, so this will yield 230, which is our answer. So students, this is the thorough method I have explained you for solving dynamic programming by tabular method. Again we'll see one problem. So now let's move to next problem. See, in this problem, this problem pertains to your area of concern. The problem reads, examination is to begin from next Monday. A boy on the night of Thursday, this usually happens with you all students, a boy on night of Thursday has 3 days, Friday, Saturday and Sunday, because from Monday he has to attend exam, has 3 days at his disposal to prepare for examination. This is a common scene. He has to appear in 3 subjects. One is mathematics, another is circuit theory, and third one is principles of management. He decides to devote a day to one subject. He decides to devote day to one subject. Now, this data given is for maths. For maths, this is 2, this is 4, 6, 10, this is 6, 6. This is the problem given. And if you devote no day for, no day means 0 days for maths, his grade point achievement without whatever knowledge he has right now at Thursday night, output will be 2, output will be for circuit theory will be 2, for principles of management 4, like that. But if we think that he devotes 1, 2 or 4, 3 full days to either of the subject, he may have decision, okay, right now I will only study mathematics for all 3 days, I will study only circuit theory for 3 days, I will study only principles of management for 3 days, or he may have a choice of selecting mixed subjects. But one condition, that he has to devote entire day, that is very important. He cannot say half day this subject, half day that subject. The condition is he has to devote all, either 1, no, 2 or 3 days to 3 of the subjects, and the objective is to maximize his grade points from this decision. So how to tackle? Now again, this problem is of discrete nature. Because why? Because your y number of days may be 0, maybe 1, maybe 2, maybe 3. Means these are greater than equal to 0. Your decision variables are greater than equal to 0 and integers. Since it is integer, now it is not mentioned in the problem, but the condition is given that he has to appear in the 3 subjects and he has to prepare for the subject in this fashion. Study days are this. So these study days are given in integers. It is not given that 0.5, 1.5, 2.5 like that. So from this particular data we have to smell that the problem belongs to discrete category. Problem belongs to discrete category. How to proceed this problem? Again, not by calculus method. We will go to find solution of this problem by calculus method. Now, one thing, this first column represents the output which we will be calling as f1 of y1. Only he thinks of maths. If he thinks of maths, gives this much weightage, this much preparation days, this will be output. This will be for f2 y2 second subject, and this will be f3 and y3. So students, our interest is, as a student, his result will be output of all the 3 subjects. So ultimately the maximum grade point will be achieved. This is very important, very very important. The maximum grade points will be achieved by combination of grade points of all the subjects, that is mathematics, then circuit theory and principles of management. So it will be nothing but sum of f1 y1 plus f2 y2 plus f3 y3, maximize z, objective function, that is maximize grade points, subjected to constraints on the number of days, constraints on number of days, that is days are only 3. So how to move ahead? See here now, the very interesting one. As I just mentioned, this is our output. This is from mathematics. This is from circuit theory, and this is from principles of management. This is from principles of management. So I am interested to get maximum grade points, but it is subjected to some condition. And what is that condition, students? The condition is that if he devotes 3 days for any subject, y1 maybe maths, y2 for circuit theory, y3 for principles of management, maximum available days are 3. So naturally under let, what will be? Let y1 be the number of days for maths, y2 be the number of days for circuit theory, and y3 be the number of days for principles of management. So if we sum of these days, y1, y2, y3, it cannot exceed 3. At the most 3 days are available at his rescue. So he can use max 3 or less than 3. That's final. Now these tables are very important. These tables are very important. This is table for, as I mentioned, maths. This table for circuit theory, and this is table for principles of management. And as rightly mentioned in from given text in the problem, we have taken these vertical columns, that if you devote 0, 1, 2, 3 for each of the subject, these are respective outcomes. These are respective outcomes. Through dynamic programming, we are finding how much days that particular student should allocate for his preparation so as to maximize his exam grade points. That is the purpose. So with this now, we have to go for various state transformation. Now, state transformations are very important. I am explaining that in every problem. State transformation. So we have seen for x2 we have many a times written as transformation based on x3 y3. So here we were having all x1, x2, x3, in all cases our number of days were less than equal to 3. So if I write for x3, this is x3, it is y1 plus y2 plus y3, which is equal to or less than 3. If I take x2, for x2 what I have to do? I have to subtract this y3 from x3. So only two stages will be there, y1 and y2. y1 and y2 is the output of x3 minus y3. So this is very important. Similarly, x1 is output transformation of x2 and y2. So this particular table is for x2, and it is on the basis of x3 minus y3. This is table for x1, which is nothing but x2 minus y2, and we have calculated transformation values. How? Satisfying this condition. So now put the values of, this is again y2. See here, use this logic for finding all values of x2. So if I put here for this value, how you get 2? For this value y3 is 0 and x3 is 2. Your formula is x3 minus y3, 2 minus 0 is 2. So this value you got 2. Now why there is dash, that we'll see. So it is 1 and 0. So 0 minus this value is 1. So minus 1 is not our value. Our values are, if you recall, the values are greater than equal to 3. In general, the values are greater than equal to 0. Maybe 1, maybe 0, maybe 2, maybe 3. So wherever we are getting such type of relationship, we are putting dash. Wherever we are getting satisfying values, we are putting values. So we got table for x2, we got table for y2, and now we will move ahead for calculating optimum solution based on this logic. Now we will use this table first for finding f2 of x2. So the same process which we have used in our earlier problem, same places where we have kept dash value is dash value. This is output only if you study maths. For studying maths for 0 days, 1 day, 2 day, 3 day, this is the score output. This is from first subproblem. This is current. We have seen such problem in previous slides. So this is f2 x2, and we are interested in maximum value. So as we did in our earlier vessel problem, for respective column addition, select maximum value from that row. So this table was for f2 of x2. In the similar fashion, we move ahead with this set of solution for second stage, and we get our third table, final table, like this. This is our final table. where we are interested in maximize grade point as F3 X3. So this is the output of second stage. As dash place, we have to place dash values, then current followed by repeated values for current locations, and this is from second stage, this is from current stage, and based on that addition of these two we get this last column. And in this last column we are interested first in all maximum values, then we have selected this value as maximum value. So maximum grade point for this student is 16. Maximum grade point for this student is 16, and how many days he should allocate, that we will see now. This 16 is result of, again there are two solutions students. This 16 suppose I consider as a result of this, therefore I have, while solving, I have made a star mark for indicating that this is the 60 which is represented this place. So this 16 is again for this column 1 is addition of this 10 and this 6. Now current decision is 6, this 6, and this 6 belongs to Y3 1, and Y3 is principles of management. So right now what we can say is he should study principles of management for 1 day. Now we will backtrack 10. Principles of management for 1 day, we will backtrack 10. If you backtrack 10, so 10 is at this point, 10 is at this point. Backtracking 10, this 10 is sum of this 10, and this 10 is sum of these 4 and 6. So current decision we have seen in previous slide, Y3 is 1, Y2 right now is 1, and 4 I have to take from this, for these 4 Y1 is 1. So this solution says that he should study each subject for 1 day, then only his maximum grade point will be 7. Likewise other solution is possible which we have studied how to calculate in previous problem. So here this is end of this particular problem, where we have solved this problem by discrete method. So try this problem multiple times, because tabular method needs lot of practice. In next lecture we will see further variety of problem from dynamic programming. So today I am ending here at this point my lecture.